into 6, 7, we're going to find imaginary zeros as well. Tomorrow we're going to bring into writing, nice block. Tomorrow we will bring into writing out equations given zeros, which is relatively straightforward. So here's what we start with. If we're going to find rational zeros, if I want to find all of my zeros for this function, I have x cubed plus 2x squared minus 11x minus 12. And I want to find all of my zeros. Yeah, it's like factoring and all that. But I can't group this to factor this. It's not going to get me anywhere. Do you guys see how that's going to work? If I take a GCF of an x cubed and a 2x squared, I take out the x squared, I have x plus 2. There's nothing left on the other side to make this factorable like the way we would normally do it by grouping. That's why we've been introduced to using synthetic division. When you are given a zero like you were yesterday, you were given either a term, like the x plus 2, or you were given the 0 is negative 3, and you are using synthetic division from there. Well, if you're just given the problem, you have to know where to start. Well, there happens to be a rule for figuring out what the zeros are to start with, and it's called the rational zero theorem. And it basically is nothing more than the fractional amounts of the constant divided by the leading term's coefficient. The constant, negative 12, divided by the leading term's coefficient. The only thing you have to remember for all of this is that it's always going to be plus and minus. Now, what you're trying to do then is that 12 and 1, you list out all the factors of 12, and you list out all the factors of 1. What are the factors of 12?
3.
It's 1, 2, 3, 4, 6, and 12, right? What are all the factors of 1? 1. So basically, you're listing out the following. Plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, and plus or minus 12 over 1. I'm over-exaggerating here by putting everything over 1. I am listing out all the possible factors of 12. I'm listing out all the possible factors of 1. Because if you have negative times negative, like a negative 1 times a negative 12 is 12, things like that.
So it's plus or minus.
Yeah. You can get some really ugly numbers and ugly fractions here. It is completely possible. So now it's just a matter of, well, that means I have, let's see, 1, 2, 3, 4, 6, and 12. I have 6, wait a second, I have 12 possible zeros to factor with. Where do you start? 1. What we're going to do here is we take this, let me move this into another slide. Once you list out all of your possible zeros, you want to start finding zeros. Well, in order to do that efficiently and easily, we use synthetic division. So you just start with 1. Use synthetic division of a 1, 2, negative 11, and negative 12. And you're checking to see if 1 is a 0 for that function. If 1 is a 0 for this function, you're going to get a 0 there. If 1 is not a 0 of the function, you won't get 0 there. So you use synthetic division. And remember, synthetic division is relatively efficient. 1, 1, 3, 3, negative 8, negative 8, negative 20. Is 1 a 0? No. What number should we check now? Negative 1. But here's the thing. Here's the thing. What happens when you find a 0? Remember how it drops down a degree? A lot of times when it drops down a degree, you guys can factor it real quick. So let's try it with negative 1. 1, 2, negative 11, negative 12. 1, negative 1, 1, negative 12, 12, and voila, we have a 0.
Ding.
So I know that I have a 0 at negative 1. So I just start making a list. Negative 1 works. I'm going to find the others. Palmer, take a deep breath. Ready? I know this started out as an x cubed, right? What is this now? What times what's negative 12 you add together to get positive 1? 4, 3. What are your other zeros? It is allowing you the synthetic division as you start listing out all of your possible zeros. Once you find one, it drops it a degree. If it's something you can factor it, you're done. If it's not something you can factor, you might have to use quadratic. You might have to use another 0. You can continue on. Okay? All you have to remember when we're finding our zeros, always list out all the factors of the constant term divided by all the factors of the leading term coefficient. And that's how it clears itself through. What's that? It can help you to start with, yeah. But if I'm having to do this via synthetic division. Yep. Yes, sir.
Can we do an example with the denominator that isn't?
Oh yeah, we'll get there. We're just starting. Yeah. No, there's really no simplistic way to go through.
So that isn't the final result.
Yeah. It said find all the rational zeros. Those are the 3 zeros.
Yeah, but don't you find?
Wait, it asks you just to find all the zeros. And this is the idea, synthetic division gives you a starting point for something you couldn't factor to start with. Once you get a 0, always check to see if it's something you can factor. And then you're done. What's the degree? If the degree is 3, that means you can have up to 3 zeros. Okay?
Is it ever going to take us, like, getting through half of, like, the...
Yeah, it can happen.
It might be like the last one that's a 0.
It could happen. If there's no rhyme or reason, that's just, I don't want to list them all out. That takes too long. That takes too long. All right. We just did this one. Duh. This guy right here. Again. I have 2x cubed minus 5x squared minus 14x plus 8. And I'm going to factor this all the way out. I'm going to find all of my zeros. Which means I have to list out all the possible factors of 8 divided by all the possible factors of 2. So my factors of 8, plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Divide all those by 1. And then I have to do the same thing with 1, 2, 4, and 8. And divide them all by 2. Because the leading term coefficient is 2, what are the factors of 2? 1 and 2. Now, you will notice something here. 2 over 2 is a repeated of 1 over 1. Do you agree? So I don't have to worry about this one. Is 4 over 2 repeated above? Yeah. Okay. Is 8 over 2 repeated above? Yeah. So in essence, that happens quite often, where you're going to have a duplicate possible 0 because of the fraction, how the fraction simplifies. So that is possible. So now you only have, well, 10, really, plus minus. So, pick one to start with. Does it matter where you start? So we have, what is it, 2, negative 5, negative 14? What was the last one? 8? Was Was it positive 8 or negative 8? Positive 8. So again, start with 1. No. Start with negative 1. No. Go with 2. I know you guys are saying both go to your table, do that. Remember, you could have non-calculator calculator stuff here, so you have to understand how to do this. There really isn't. This is the easiest way to set a lot of this stuff up. I'm telling you. And if you think about it, you're able to factor stuff that you couldn't factor before. And synthetic division is about as efficient of a math problem you can do. Hey, I found one. Ding. I have one at negative 2. So I have 2x squared, negative 9x, and a 4. What times what is 8? You add together to get negative 9. Negative 8, negative 1, right? So I could try and factor it right like that. So I just move this down a little bit here. What are your other zeros then?
Wait, where do you get that negative 8 and negative 4?
What I did is I did a split middle term of 2x squared minus 9x plus 4. What are my other two zeros then, guys? 1/2 and 4. So my answer would have been negative 2, 1/2, and 4. Now, could you have started with the fractional ones first if you wanted to? Yeah. It doesn't matter which one you start with. You can just pick something in the middle. You can randomly select whichever one you want to start with. I recommend starting with 1 and working my way from there. It's pretty straightforward. Okay? It's not difficult. This is the easiest way to do this.
The difference between simplicity and speed.
Yeah, not much. Which leads us to the fundamental theorem of algebra. As of right now, we have just been working with the real stuff, the rational answers. Now we're going to get into irrational answers, which means we can have imaginary solutions.
Why is that just?
Because it has to. Because if there's always an optimist, there's a pessimist. All right? Yeah. Now, here's what the fundamental theorem of algebra basically states. I don't like the way the book writes it out. Basically, it's telling you what your degree is, gives you your number of possible zeros. Okay? Now, if we've looked at stuff in the past, you all right, Mr. May? Math is not fun today. It's okay. If you recall when we looked at something where it's x squared plus 2, and we graphed that, it had, or basically let's just say we had f of x was x squared. It was a parabola. It was at the origin, and it had 1, 0, correct? The 0 was at 0. But it being a second degree polynomial, it should have 2 zeros, right? what happens here is when we start to list out our zeros, if it's a repeated 0, you write it twice. That's what you're looking for. Okay? It's just written out twice if it's a repeated 0. So this being a 5th degree, I could have up to 5 possible zeros. There might be 2 of them to be the same number, 3 of them might be the same number, and so on. But again, what I want to do here is by finding all of my possible zeros, I start by listing out the factors of the constant divided by the factors of the leading term coefficient. What are the factors of 6? 1, 2, 3, 6. What are the factors of 1? 1. So we start again by plus or minus 1 over 1, plus or minus. Do I have to write it over 1 because my leading term is 1? Are we okay with that if I just write it as 1, 2, 3, and 6? And again, does it matter where you start with your synthetic? So we have 1, negative 2, 8. Oh, what did I forget? Very good.
Oh my
Placeholder.
goodness.
Placeholder rule still holds? No. I'm a creature of habit. Hey!
Oh my goodness.
We found a 0. All right. So we found a 0. I know I have a 0 at positive 1. Okay? I have a new term. What's the degree of my new term? To the 4th, right? It's at the 4th. I'm not going to want to try and factor that. That's got 5 terms. We really can't factor that. So I'm going to use synthetic division again.
Double.
What's that?
It's like double.
I know. So we use synthetic again. When I use synthetic again, remember we have our list of possible zeros. I just continue to reuse that list. Yes, sir.
Wait, why are you reusing that?
Yeah, you did just find it.
That's just one of the zeros. There's up to 4 more I gotta find.
So it's not.
So-
Well, why are you not reusing what you just?
Well, in this case, what's my last term? What's my constant? What are all the factors of 6? 1, 2, 3, and 6. So I'm going to use synthetic division again. This is an x to the 4th, x cubed, x squared, x, and my constant. I don't need to worry about that 0. My list of constants are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And I just start over again at 1. I'm synthetically dividing out each time. I might have to change this at, oops, I might have to change this as I'm working my way down through them.
Wait, so if that hadn't remained of 6, what would you do?
Just 1.
If it was like a 4, I'd do plus or minus 1, plus or minus 2, plus or minus 2. Yeah, but it's real quick.
So like on the next one?
Yeah.
I was just confused because I thought like you kept the same set,
Mhm.
whether it remained 6 or not.
More often than not, you're going to use this.
So can you use 1 again?
Yeah, I'm using 1 again. I'm starting over with 1 again. So I got now 1, 1, 0, 0, negative 1, negative 1, 6, 6, and a 0.
Yeah, so it works.
Dang.
All right. Yes, sir.
Okay, normally where you factor out, why don't you just start over the list that you already had?
It just so happened that I am. Because it is the same list.
How many times do you do it?
Because I ended up in a 6, right?
But I'm saying all the other coefficients are different.
Oh, I don't care about those. I'm worried about the constant. I always worry about the constant. I'm listing out my possibles. That's all I'm looking at. You take your constant. The other ones, it doesn't matter. You're just bringing those down around. Because remember, each time you write this out, what happened here, we found that 1 was a 0. When I found that 1 was a 0, in this part, when I saw that 1 was a 0, that meant there's a term, x minus 1. And I'm left with, on the other part, we are left with what? x to the fourth plus x minus x cubed minus x squared plus 7x minus 6. I was left with that. So now I'm doing this again, I'm trying to continue to factor this out and find the next term that comes out. I'm trying to factor this each time. So I'm looking at the constant every time.
Well, what if it was a negative 6 situation?
Then I make a different list. That's all. I just make a different list.
But
So
now
you
since
keep
there's
going?
4 terms, we can just factor.
Well, in this case here, there's not 4 terms, there's 5.
Yeah, but after we factored it.
Now, when you're left here, though, you had another 0 again at 1.
Yeah.
Now, this is actually x cubed minus x plus 6. Can you factor that? No. So you have to continue with your synthetic.
We must go deeper.
You have to continue with your synthetic. Stupid Wednesdays. What's that? If there's two ones, basically that means right now you have an x minus 1 times what we have is x cubed minus x plus 6 as of right now. So I would continue with my synthetic here, and I would try 1 and then continue with that. Okay? So we'll continue working with 6, 7.
Wait, so what's the answer? Finish this problem.
We don't have time to finish it right now. But you're basically doing the same thing over and over and over again. So what I want us to start up with tonight from 6.6. Let's see.
No. Well, you always gotta add that 1, so it's 10.
Start with those. Okay? Start with those right now. In the 6.7, I did not give you anything that had an imaginary solution. We'll get into more of that tomorrow, and also rewriting out the polynomials given our zeros.
And I have to go to college too.
Yep.
I have to do my study. And study hall.
Are you finishing? Okay.